Greetings, Algebra 2 students. This is Dr. Heron, and this is the notes video for 5.1. Unit 5 starts to look at probability and a little bit of statistics, but mostly probability and kind of calculating how things can happen. Okay, so consider something like this. The number of license plates for a state is too big to count by simply listing all the possibilities, okay? I can't sit there and just go like A, 0, 0, 0, A, 0, 0, 1, and so on. That would take forever. There is a way faster way to do it, and that is called the fundamental counting principle. The fundamental counting principle basically says this: if there are m ways to do one item or make one choice, or any possibility, if there's m possibilities of one thing and n possibilities of another thing, then the total possibilities is m times n, okay? So how does that translate to license plates? For the license plates, that basically means for the 3 letters and the 3 numbers, I've got 26 choices for that, 26 choices for that, 26 choices for that. Then for the numbers, I've got 0 to 9, so I've got 10 times 10 times 10. Okay, so my total is going to be 26 times 26 times 26 times 10 times 10 times 10. So it's going to be 757,6. So 17,576,000 possibilities of license plates. And that doesn't even include vanity plates. Okay, so a couple of terminology pieces to be familiar with. One, the outcome of a single trial. Okay, an outcome is the result of a single trial. What does that mean? So flip a coin and you get heads. Heads would be an outcome. Okay, so if you're flipping a coin, you're going to get heads, that's going to be your answer. Otherwise, rolling a dice and getting a 6. Though that would be an option as well, getting a 6. So sample space is be the set of all possible outcomes. This is basically anything that could happen, everything that could happen. So if I roll a dice, rolling 1 die, my sample space is going to be 1 through 6. Okay, that's everything that could happen. If I roll 1 die, that's kind of everything that could happen. An event is basically going to be a combination of outcomes or one outcome of some event. So if I said, flipping a coin, rolling a die, or drawing a card, or anything like that would all be considered events. Okay? So, independent versus dependent events. Independent events, the two don't affect each other, okay? So if I roll a dice, if I roll 2 dice, okay, one doesn't affect the other. So rolling 2 dice, one doesn't affect the other. Or if I said, flip a coin and draw a card. Those two things are independent, they don't impact each other. So what would impact each other? Well, an easy one would be if I draw a card and I keep the card and I draw another card. Okay, so this would be called without replacement. Okay, that says replacement. So the fundamental counting principle, we kind of said this a couple slides ago. there's m ways to do one thing and n ways to do another thing, then my all possible outcomes is going to just be m times n. So if I have 4 events occurring, then the possible number of ways that something can happen is going to be the product, the multiplication of all 4 of those, okay? So if I consider this problem, sandwich car offers customer a choice of a hamburger, chicken, or fish on either a plain or sesame seed bun. How many different combinations are possible? Well, for me, for this individual person, I can have a hamburger, I can have chicken, or I can have fish, and either one of those can be on a plain or sesame seed bun. So I'm going to have 6 possibilities, 2, 2, and 2, so 6 possibilities. The other option would be just to say, 3 times 2, because I'm picking one of the meats and I'm picking one of the breads. All right, so are choosing a bun or is choosing a meat and a bun independent or dependent? It's going to be independent because one has nothing to do with the other. It's not like I said, well, if I pick the chicken, I'm not allowed to pick a plain bun. Okay, those would be dependent, but though it's independent because one has no impact on the other. All right, checking a voicemail, owners might have to enter a 3-digit code depending on what it is. Is it going to be an independent or dependent event? How many codes are possible? So the question you got to ask yourself is, if it is independent, that means that one number has no impact on the other. So that means if I have a 3-digit code, I could have anything from 0 to 9 for each one. So that's going to be 1,000 different choices. All right, if I said nothing could repeat, so if I said dependent, I would say, no number can repeat. That would be 10 options for the first one. Then once I pick that one, I can't repeat it, so it's going to be 9 options for the second number. And my last number is going to be 8. So that would only give me 720 choices. Okay, so if numbers couldn't repeat, that would make it dependent. Okay, Carly wants to take 6 different classes this year, assuming that each class is offered each period. How many different schedules could she have? Well, 6 different classes means if she has already a class, she can't take it again. So first period, second period, third period, fourth period, fifth period, sixth period. So what she can do is say, well, you got 6 options for the first one, 5 options for the second one, 4, 3, 2, and 1 for your options. Okay, this is going to be dependent because once I pick a class, I'm not picking it again. Okay, so that's going to be 720 different options. Okay, so garage door's got a 10-digit keypad, and the code is a 4-digit code. How many options are possible? Well, we have a 4-digit code, and I can repeat the number. So I could in theory have like 1, 1, 1, 1. That's an option, okay? So that means I've got 10 times 10 times 10 times 10. So that's going to be 10 to the 4th, which is just 10,000 choices. Okay, so I've got 10,000 options for that one. Okay, each player in the game board uses a different game piece. Out of 6, 4 players are playing the game. How many different ways can the players choose their game piece? So I've got 4 players. First player's got 6 different choices. Okay, this would be a dependent because once one of the tokens is gone, you can no longer choose that one. All right, so first person has got 6 options. Second person, you take that first one away, has got 5 options. The third player's got 4 options, and the last player's got 3 options. So my total possibilities for 4 people is going to be 360 ways. All right, short note video this time. please look at whether or not you've got dependent or independent, and then consider kind of what the different possibilities are and how many I'm going to have for each one of these.